Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about time series data analysis. Even before I proceed to talk about how exactly do we perform time series analysis, may I request you to subscribe to my channel, also like and share my videos. Let's begin by asking a simple question. What exactly do we mean by time series data? Time series data is also called as time-stamped data. This is the data wherein the information is arranged as per a chronological order. The chronology could be as per day or week. It could also be at a monthly level, quarterly level, or yearly level. I'm sure most of you would have seen the data for stock prices. Stock price data is typically an example of time series data. You may have information about the stock prices for last 10 years, which is a typical example of time series data. Just as we have stock price data, we can also think of examples like Bitcoin prices. You can think of the yield of rice. You can think of rice production or wheat production or production of any other essential commodities. All these are examples of typical time series data. Time series data analysis is widely used in the financial sector. It can be used to model very complex behavior of a particular variable and make useful predictions well ahead of time. In this video, I will be using a real-time data of the WPI or the wholesale price index of rice. We will be talking about the behavior of rice for the last 10 years. We'll also be building a predictive model which will tell us how will the prices of rice fluctuate in the next year. As you can see here, I'm working on a tool which is called as SPSS. Let me quickly pull out the data for wholesale price index of rice. I'll go to the file menu. Here you see what is called as recently used data. Right at the top, I have created a data which is called as training data. You can see here, in the training data, I've got 5 variables. The very first variable is the serial number. Second variable here is the date variable. The third variable is year. Fourth variable is month. And the last variable that I have is the wholesale price index of rice. For example, if you look at January 2001, the wholesale price index of rice was 164. If you look at February 2001, the wholesale price index of rice reduced slightly to 163. Then in the month of March, the wholesale price index increased to 165. Like this, when you look at the last row here, the last row comprises of data for April 2009. So roughly, I have got 9 years of data for wholesale price index of rice. You can see here, this is the training data. Now, I will be modeling the behavior of rice. Even before you jump to any statistical model, what we need to do is we need to inspect the behavior of rice. We need to inspect the behavior of this particular variable. In SPSS, there are a lot of complex models. Primarily, I would like to draw your attention to 3 important models. One is what is called as the expert modeler feature, which I will be using in this video. The second model is the exponential smoothing model, which is further broken down into non-seasonal models as well as seasonal models. Under the exponential smoothing non-seasonal models, we have simple model, Holt's model, Brown's model, damped model. Further, in the exponential seasonal model, we have the simple model, Winters additive and Winters multiplicative model in SPSS. The last class of models that we have is what is called as the ARIMA model. Within ARIMA, again, we have the non-seasonal components as well as the seasonal component. It is sufficient to remember for the purpose of this video that we have 3 classes of models. One is the expert modeler, second one is exponential smoothing, and the third one is ARIMA model. We will be using the expert modeler in the first stage of analysis. When you have this variable, the very first step that you need to perform to model any time series data is to simply construct a time series plot. A time series plot tells you a lot about the behavior of this particular variable. How do you construct a time series plot in SPSS? To construct a time series plot, you can click on the Analyze menu. You can click on the option which is called as Forecasting. I repeat, in the Analyze menu, you have an option which is called as Forecasting. Now, within this particular option, there are several different features that are present. It's very easy to be intimidated with so many features, but let me make it simple for you. We can identify what is called as sequence chart. You can see here, this is the option that you need to click whenever you want to perform a time series plot. Let me go ahead and click on this particular button. This opens up a new dialog box, which is called as the sequence charts dialog box. In the left side, you have all the variables that are present in the data set. There are 5 different variables that are present in the data set, which are listed here. And on the right side, you have a box mentioned for variables. Similarly, you have the time axis labels. Let's look at the variables box. Under the variables section, I will be using rise because I would like to study the behavior of rise. As the name itself suggests, you have time axis labels. In this, you can specify any date variable. Let me go ahead and choose the date variable under the time axis labels. This should be sufficient for us to look at the behavior of the variable rise. Once you have made these selections, you can go ahead and click on the OK button. You can see here, this is the output window. In SPSS, there are 2 separate windows, one for data, the second one is for output. Let me scroll down. You can see here, this is how the time series for wholesale price index of rice looks like. In the x-axis, we have the time variable, that is January 2001. Then we have May, September, again January 2002, all the way up to January 2009. So we have 9 years of data along the x-axis. Please observe the y-axis. The y-axis represents the wholesale price index of rice. The minimum value here is 160 and the maximum is 240. Let's trace the path of this particular variable. As you can see here, the path of this particular variable is on an upward trend. So clearly, there is a trend component that is present in the data. Now, from January 2001 all the way up to January 2006, almost for 5 years, in fact, for 6 years, you don't see too much of a trend. In fact, it is well within the range of 160 and 180. Post September 2006, you can see there is a upward trend in the behavior of the WPI of rice. So clearly, there is a trend that is present in the data. Whenever you see trend is the enemy of stationarity. Remember, for most of these statistical models, one of the important assumptions that we make is that the data should be stationary. Stationary with respect to mean, stationary with respect to variance as well. So when there is a trend component, it automatically implies that your data is non-stationary. So as you can clearly see, we have established the fact that there is trend in the data. Secondly, the fact that we have random spikes here. You could see there are certain spikes here, but we don't have any sharp spike as such. So there could be a hint of seasonality as well in the WPI of rice. So we have trend, we have seasonality as well in this particular variable. Now, once you have established the fact that there is trend, there is a bit of seasonality in the data, what is the next part? The next part is to specify an appropriate mathematical model to learn the behavior of WPI of rice. To do this, let me come back to my data. To specify a model, what I'll do is, in step 2, I'll go to the Analyze menu, come to the option Forecasting. Here, the second option from the top is Create Traditional Models. I repeat, here we have an option which is called as Create Traditional Models. When I open up this particular dialog box, you can see here, this dialog box is the dialog box for time series modeler. In the left-hand side, you can see 4 important variables, and on the right-hand side, you can see a box for dependent variable as well as a box for independent variables. There are 3 options. May I draw your attention to the method that we can use to model this data? The method here is what is called as expert modeler, which means that SPSS itself will identify which is the best model to be used for your data. If you click on the drop-down menu, there are other interesting models as well, which is called as exponential smoothing as well as ARIMA. I will not be using the second and the third option. I will be using the expert modeler feature for this video. Now, when it comes to the box for dependent variable, let me select the variable rice and push it into the box for dependent variable. I'm not going to use any of the independent variables here in this video. In the subsequent videos, I will be using independent variables as well. So I've got rice. Let me now go to Save button. I would like to generate 3 important items. The first one is the predicted value of rice. Second one is the lower confidence limit. And the third one is the upper confidence limit. Now, when you choose these 3 variables, what this does is it will generate 3 new variables in your SPSS data set. So we have requested SPSS to give us the predicted value as well as the lower confidence limit and the upper confidence limit. The last task that I'll be performing is by going to the Options tab. We have to specify here the forecast period. Now, for time being, I'll ignore this particular option and I'll simply click on OK. You can see here in the output window, SPSS has generated the results. The first thing that we need to observe is the model description table. SPSS is telling us that it is using ARIMA 110, and the parameters for the seasonal component would be 000. So you have AR, I, and MA. These are the 3 components, and SPSS has identified ARIMA 110 as the best model out of the list of the models at the backend. There is certain important information that is printed under the model summary table. What is this information? You have the stationary R squared, then you have the R squared value, you have the Ramsey value or the root mean square error. Further, you have mean absolute percentage error, you have the max absolute percentage error, you have the mean absolute error, maximum absolute error, and normalized BIC or Bayesian information criteria. All these are nothing but the model fit index. Primarily, you can look at stationary R square. Higher the value of the stationary R square, better the fit. Lower the value of stationary R square, it usually implies that the model fits the data poorly. Sometimes people also look at what is called as MAPE or mean absolute percentage error. Closer the value of MAPE to 0, better the model. If the value of MAPE is high, it means that the predictions are not really accurate. This is giving you a whole lot of metrics here. What I would like to do is move on to the next table, which is called as the model statistics. You can see here under the model statistic, you are getting the stationary R square of 0.07. To check whether the model fits the data well or not, we are using a statistic which is called as ljung-Box statistic. It's pronounced as ljung-Box statistic. The ljung-Box statistic value is 8.6 with a degrees of freedom of 17. And finally, this also reports the significance level. What is the significance level or the significance level or the p-value? The significance level that is being reported here is 0.951. I repeat, the significance level that is being reported here is 0.951. Since the p-value is greater than 0.05, we can go ahead and conclude that the model fits the data well. So what we can conclude is that the ARIMA model that you saw earlier is a good model, and this particular model fits the data well. What you're seeing here is nothing but a time series plot with the observed data. You can see here, this is the observed data that we have been shown. Now, we can't make any decision just by looking at the observed data. We need to compare the behavior of the observed data with the predicted data. If the behavior of the observed data and the predicted data is very, very close to each other, then we can say that the model is accurate. In case there's a big gap between actual and predicted, it implies that the model is poor. Now, let's go back to the SPSS file. So this is the SPSS file. Here, you can see there are three new variables that are created. The first is the predicted value. The second one is the LCL value. And the third variable here is what is called as UCL. We have rise, which is the actual value. We have the predicted value. We have the LCL value, as well as we have the UCL value. Let me go to the last record here. You can see here, the last record here is April 2009. So till April 2009, you have the actual data as well as the predicted data. It will be worthwhile to make a comparison between actual and predicted. Now, to do this, I'll go back to the Analyze menu. In the Analyze menu, I will look at the forecasting option. Here, let me go to the option Sequence Chart. You're already familiar with the sequence chart. This will help you produce the time series graph. Let me go ahead and click on the sequence chart. In the sequence chart, under the variable section, you have rise. This is the actual value of rise. Along with the actual value of rise, we can also push in the predictions and the lower confidence limit and the upper confidence limit. So we have actual data, we have the predicted values, LCL, as well as UCL. Let me go ahead and click on OK. Some of these output is familiar. What is really interesting to see here would be this particular graph. Please note that we have the blue line. The blue line represents the actual data of rise, and the red line represents the predicted values of rise. You also have the green line, which represents the LCL, and further you have the UCL value. Since the blue line and the red line are very, very close to each other, you can see here consistently the blue line and the red lines are very, very close to each other. You can go ahead and say that the model predicted values and the actual data are very, very close to each other. But there is a problem here. What is that problem? The behavior of time series data is not assessed for the current data. We always assess it for future data. So what we need to do is to test this particular model, whether this particular model is doing good or not. We need to perform out of time validation. Now, the next step that I'll be doing is out of time validation. So let me go back to SPSS. I have data till April 2009. As you can see here, I don't have future data. That is, I would like to have data till April 2010. Now, there is a separate file which I've created. Let me show this particular file to you. I can go to File menu. and look at recently used data. Yes, this is recently used data. I would like to click on test data. You can see here, like before, you have 5 variables: serial number, date, year, month, and the WPI of rice. But what is interesting here is that we have 10 years of data in this particular file. We have data from January 2001. If I scroll to the last record, here you have April 2010. So you can see here, we have 10 years of data. Now, what I intend to do is, I like to go back to the training data. Go back to training data. And after going back to training data, I would like to generate the predictions for 1 year ahead. From 2009, I will be creating prediction till April 2010. Compare the predicted data with the actual data and see the performance of the model. You can see at the top left side, I've named this file as test data. This is the test data. This is the SPSS icon. Let me click on the training data, which has information till April 2009. Let me remove the earlier predictions. This is unnecessarily going to cause a lot of confusion. So let me delete it. How do I delete it? Simply right click and say clear. So from 2001 all the way up to 2009, I have data. Now, how do you perform out of time validation? To perform out of time validation, we can go to the analyze menu. Here again, I'll come back to the forecasting option. The second item from the top is create traditional models. I repeat, we can create traditional models here. This will take me to the time series modeler. You can see here the dependent variable we have already specified as rice. The default model is the expert modeler feature. When it comes to save, I'll be saving the predicted values, the LCL and the UCL. Now, there's one more additional thing that I'd like to do, which is to go to options and select the forecast period. Look at this. This is the forecast period. Let me choose the option first case after the end of estimation period through a specified date. So I would like to generate prediction not till 2009, but till 2010. 1 year ahead, I would like SPSS to generate predictions. Why? Because I would like to check my predictions 1 year forward with the actual data. And if the actual and the predicted match, then it means that the model is good. If the actual and predicted do not match, then we are in for a problem. Then we are in trouble. So the year is 2010 and the month is 4. So till April 2010, I'm requesting SPSS to generate predictions. Let me now go ahead and click on OK. You can see here in the SPSS dataset, there are 3 new variables that are created. One is the predicted value of rice. Then we have the LCL and the UCL. May I draw your attention to a very, very important point here. When I look at the last row here, let me scroll to the last row. You can see here, April 2010. So we have the predictions for 1 year ahead of time. We have the predicted values, the LCL, as well as the UCL. So this is very, very important. To the left side, when you look at rice, let me just show you the behavior of rice. So this is the data. You see a lot of missing cases. Why missing cases? Because from May 2009 onwards, it is quite clear. From May 2009 onwards, there are a lot of missing cases. We have the information only till April 2009 when it comes to the actual data. But look at the next variable. We've been able to generate the predictions 1 year ahead of time. Now, the question is, are these predictions reliable? Now, to check the reliability of these predictions, what I'm going to do is I'm going to select the last 3 variables. Let me select these 3 variables, right click on these 3 variables and choose the option cut. I will go to the test data set. You can see here, this is the test data set. I'm right now in the test data set. I'm going to paste it next to the actual values of rise. So this is very interesting because what we have right now is the actual value of rise, and next to it, we have the predicted value of rise. So we would like to compare the actual versus the predicted. Let me scroll to the last record here. You can see here, when you look at year, we have 2010, that is till April 2010, we have both the actual data as well as the predicted data. What we are going to do now is to go to the Analyze menu, then click on the Forecasting button. Here, the second option from the top is Create Traditional Models. We will not be creating any model here. We will be inspecting the performance of the already created model. So to do this, we can click on Sequence Chart. Once I click on the sequence chart, you can see here, this is the sequence chart dialog box. Under the variable box, we have nothing. So we can push the variable rise under the variable section. We can also push the variable predicted wholesale price index of rise under the variable section. Under the time axis labels, what I will do is to choose the date variable. In the x-axis, I'll have the date variable. I'll be comparing the actual versus the predicted. There's one more interesting button here which says timelines. If we click on this option timelines, this will produce a new dialog box. This will allow me customization of the graph. I'll specify the year as 2009. The month would be April. So let me specify the month as 4. This will just create a reference line so that it's very easy for me to explain the out of time validation. Once you've specified this, please click on continue. As you can see here, actual data of rise, predicted data of rise. Now we can click on the OK button. This is the SPSS output window. You can see here the sequence plot has been generated. Let me scroll down. So this is the time series plot that we have. What you see here is from January up to May 2009. The blue line here, when you look at the legend here, the blue line represents actual data and the red line represents predicted values. For 9 years, that is from January 2001 all the way up to May 2009, the blue line and the red line are very, very close to each other. In fact, the blue line is hugging the red line, implying that these two lines and the behavior of these two lines are very, very close, which means that in the training data, our model has done an excellent job. It is basically learning the behavior or the characteristic very, very well. So the ARIMA 110 model that we had built earlier is doing an excellent job. Let me just look at the name of the model. The model that we had built is ARIMA 110. Yes, I'm right. The ARIMA 110 model that we had built has done an excellent job of learning the characteristics for the training data. But here is the problem. You can see here, beyond the reference line, please observe the behavior of the blue line, which is the actual data, with that of the red line. The blue line is going up. The trend is upwards, which means that the blue line, the actual wholesale price index of rise post 2009 has increased. But what is the red line or the predicted line telling me? The red line is saying that no, the rise price is not increasing. It is going to remain constant, which is a big, big problem, which is a big flaw here. You can clearly see here, had the red line also climbed up along with the blue line, then we could have said that ARIMA 110 model is a good model. But here we clearly see that there's a huge gap between the blue line and the red line, and the red line is not at all tracing the path that the blue line is tracing, which is a clear indication that the expert modeler feature, which has given you ARIMA 110 is a faulty model. It's a flawed model, which brings me to a very, very crucial point that I'd like to make here. Many times there are softwares, many times there are programming languages which have this inbuilt feature, which is called as the expert modeler feature. You also have certain features in Python, which is called as pyramid and other features, which give you automated model. It is good that these softwares are trying to help the users by giving you expert modeler feature, but I would like to always caution you against the output produced by expert modeler feature, simply because the results might not serve you well. At the back end, what most of these expert modeler feature does is it would run a quick model, and out of the list of the models that it has run at the back end, let's say it would run ARIMA 110, 010, 213, it would just change the parameters of ARIMA, exponential smoothing, so on and so forth, produce a list of stationary R-square values, and whichever model has the highest stationary R-square value, it will choose as the champion model. But this is the tragedy of most of these models, merely because the stationary R-square or any of the other model fit indices are high, we cannot go ahead and claim that the predictions will be accurate. At the end of the day, expert modeler feature is not a substitute for human thinking. Human discretion is very, very much necessary when we build any model, right? So this is one of the valuable lessons that we can pick up. Merely because there's a feature which says expert, which claims to be an expert in particular domain, it does not mean that we should always rely on its predictions. If you were to go on to implement the predictions generated from expert modeler, we will definitely have wrong predictions. Wrong predictions in this case basically means life and death. It would mean, since we're talking about wholesale price index of rice, it would mean that we will be making a wrong assessment. We'll be forecasting wrong values for the WPI, which will result in a lot of chaos. That's the reason why we should always take the results from many of these models with a pinch of salt. How do we rectify this problem? Is there a way in which we can address this issue? That is something which I'll be talking in the subsequent videos. With this, I have come to the end of today's video. In today's video, we've spent some time looking at time series models. We've looked at sequence chart. We tried to understand the behavior of expert modeler. We constructed time series plot. We used the expert modeler feature to generate predictions. And after generating predictions, we compared the actual versus the predicted. Further, we went on to perform out-of-time prediction. Now, the moment we perform out-of-time validation or out-of-time prediction, that's where the predictions were found wanting. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much once again. Have a great day ahead.